Okay, this is the Professor, CBMD PhD, and today's Thursday, October 26, 2023. It is 2:06 and 9 seconds, AM Eastern Standard Time, and today's research, biomedical molecule. So let's hop to it here. The scientists shed light on potential breakthrough, biomedical molecule, date October 24th, 2023. Source: National Accelerator Laboratory. Developing a new light-activated method to produce the molecule opens doors for future biomedical applications. Nitroxide has many of the same physiological effects of nitric oxide, such as its ability to fight germs, prevent blood clots, and relax and dilate blood vessels, with additional therapeutic properties such as efficacy in treating heart failure, as well as more potent antioxidant activity and wound healing. However, it is not a chemically long-lived species, so methods that enable its targeted delivery are key to future biomedical applications. And to address this challenge, the team focused on a unique molecule, an iron nitrosyl complex, FeNO. The research aimed to understand the intricate properties of the FeNO bond, both before and after light exposure, to navigate the complexities of nitroxide production. They discovered that by exposing the molecule to optical light, they could break its bond, potentially producing nitroxide. Although this research is fundamental in nature, the hope is that other researchers can take what they learn from this molecule and build therapeutic technologies off of it by optimizing similar molecules for medicine. The idea would be to get a molecule that releases HNO in the body where it is needed and shine light on it to release it for the therapeutic properties. One of the challenges the team faced was the ambiguous distribution of electrons between the iron atom and the nitrosyl ligand, a molecular ion that binds to essential metal, atom or ion, and the FeNO complex, which limits how much information can be gained using traditional methods. The scientists employed advanced X-ray spectroscopic techniques that allowed them to peer deeper into the chemical properties of the molecule and its bond, providing a more complete picture of the FeNO system and how it responds to light. And to follow up the scientists' plan to further explore the intricacies of the bond-breaking process and how to optimize the production of nitroxide or nitric oxide, they're also considering replacing iron with other metals to better understand the photoproduction process. In this research, they understand the starting molecule and its final products. After shining light on it, there are still a lot of nuances in the actual bond breaking and release of nitroxide from this molecule that need to be explored. One step in the process decides the release of nitroxide instead of nitric oxide. How can we structurally tune the system to produce either molecule? As this work helps to build an understanding of which properties to monitor in future experiments, where scientists will be able to take real-time snapshots of the nitroxide photogeneration process. The information they gain highlights the power of this approach and serves as a blueprint for future studies on these and similar molecules in the future that will extend the studies. The research holds promise for the medical community and patients who might benefit from its future applications, although they are still far away from using light on these molecules to treat serious cardiovascular conditions. Fundamental insights in these molecules lay substantial groundwork for applied research in the future. The scientific investigators and microbiologists say this may lead to entirely new ways to use light to treat cardiovascular conditions, microbial infections, cancer, and other health conditions. And this is a professor of space technology, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.